A waterhole in South Africa. Dry season, the water pulling back. A speaker sits hidden in the brush, wired to a camera trap. An animal comes to drink, the camera trips, and the speaker plays a recording. The recording is two people talking, normal volume, no shouting. Other nights, that same speaker played a lion's roar. The result came out backwards. Hearing people talk, the animals fled about twice as often as for the lion. They left the water about 40% faster. That's what we're working out tonight. How an ordinary talking voice beats a lion. The answer isn't in the sound. The setup went into a South African reserve in 2023. They chose a waterhole for a reason. Anything else, an animal can go around. Water, it can't. The method was plain. The camera waits, and the animal trips it. 4 sounds rotated through. People talking, lions roaring. Hunting sounds, meaning dogs and gunshots. And bird calls, as a control. One piece of that design carries everything. Nobody was there. No one crouched in the brush working a switch. No human scent. No shape to see. All the animal got was sound out of a speaker. 19 species, 4,238 separate trials. Elephants, rhinos, giraffes, zebra, kudu, warthog. Nearly all reacted harder to the sound of people talking. Now the edges, before this gets pushed too far. This is one reserve and one kind of water source. Not every animal on Earth. And a dry season waterhole is already a nervous place. Everything has to come, and everything is watching everything else. But fold all of it in, and the backwards result still stands. The obvious explanation is that the human voice was louder, or harsher. That isn't how the recording was made. Two people in ordinary conversation, at ordinary volume, no screaming, no gunshot, nothing built to grate. On the other side, a real lion's roar. One of the loudest things on that whole landscape. So here, the louder sound got the weaker response. These animals have handled a lion's roar for hundreds of thousands of years. They know the drill. Lift the head, find the direction, decide whether to leave. Two people chatting, they've had far less time with. Say the number carefully. Of the 19 species tested, 95% reacted more strongly to human voices on at least one of two measures: how likely they were to run, or how fast they left. Not 95% ran. 95% were more sensitive on at least one measure. Those are different sentences. Everything after this is built on the accurate one. So what they're reacting to isn't the sound, it's what it stands for. People are near. The sound is only a cue. What it points at isn't inside it. Which changes the question. Is that pointing something the animal learned in its own lifetime, or something it was born carrying? Try the cheapest explanation first. Those particular animals learned it. That part of Africa has had poaching, hunting, and a long history of people moving through. Generation after generation took losses and learned to get out of the way. Reasonable enough, so change continents. Tasmania, 2024. Different species, different history, no lions there. 4 native marsupials that grew up inside a completely different predator lineup, plus introduced fallow deer. Same method, hidden speakers and recordings, people talking, dogs barking, local predators, and a control. The direction held. Overall, human voices drew the strongest vigilance. The native marsupials fled the human voice at 2.4 times the rate of the next strongest sound. That was a barking dog. 2 continents, 2 sets of species, pointing the same way. But one more step here is easy and dangerous. Same direction doesn't mean same cause. Tasmanian marsupials and zebra at an African waterhole never shared a history or a set of predators. 2 places pointing the same way tells you this is widespread. It doesn't tell you one mechanism sits underneath. And Tasmania is still only those Tasmanian species. Still, 2 places agreeing sets up a conclusion that sounds tidy, so it must be hardwired, unchangeable. That step goes too far too. Inside hunting ban areas in China, researchers ran similar playback tests on roe deer and wild boar. Hunting is banned there, nothing is killing them now. And they still fled from human voices as readily as from a leopard, sometimes more. That half removes one explanation, that an animal only stays afraid while something is actively hunting it. But the same data has another half. Play the same sound over and over, and the response drops off. The researchers called it habituation-like. Take both halves together. One side, no present threat, and it's still afraid. The other side, repeat the same stimulus, and that reaction falls. Weaker is a change in behavior you can see. It doesn't mean the fear was erased. It may only mean this sound, in this place, has stopped being worth that much effort for now. So it isn't hardwired, and it isn't being propped up by gunfire right now. It looks more like a judgment still in use, not a fixed reflex, and so far, the thing being measured has stayed the same. Run, or don't run. That takes a few seconds. One experiment did the accounting past those few seconds. An island, with raccoons foraging in the intertidal zone. The researchers did one thing. They played predator sound, dogs barking, No dogs, only the sound. The raccoons foraged less. Less time working the flats, more time with their heads up. A raccoon turning over crabs in the wet rocks only has to look up twice more, and that night it eats less. Then it went one level down. The crabs and fish they stopped eating went up in number. That isn't one animal missing one meal. That's the numbers along a stretch of coastline getting rearranged. Not one extra predator arrived, not one actual kill, only sound. One thing has to stay clear. This was a dog sound experiment, not a human voice experiment. It can't be used to prove human voices do the same thing. It proves one thing, and that one is already heavy. Fear built out of nothing but sound doesn't stop at the animal that got frightened. It travels down into what gets eaten, how much, and how much is left. Fear is a cost by itself. Nothing has to actually get eaten. Back to the human voice. If ordinary talk moves animals off water better than a lion does, it isn't only a finding, it's a switch you can press play on. So why not use it? Ring the places rhinos move through with speakers, and scatter the animals before a poacher gets close. It sounds like a fence with no wire in it. People have discussed that seriously, but 3 bills come due first. The first is habituation. Run the same sound repeatedly, and the response drops. A fence that expires on its own only works for a while. The second is stress. Keeping an animal on guard costs something. A drink skipped, a meal missed, more time watching. It all goes on its account. In the dry season, a skipped drink isn't small. Use fear as a fence, and the price is making it pay that bill continuously. And the one paying isn't the poacher. It's the animal you were trying to protect. The third is easiest to miss. What you're changing isn't one animal's behavior. Those crabs and fish said it plainly. Press play, and you change what a whole area eats, and how much. So this isn't a zero-risk way to move animals off. Stress, habituation, and the knock-on effects through the system each need their own assessment. Effective doesn't get to mean harmless. Leave the tool question there. Because when you set these experiments side by side, what's left isn't a technical problem. 3 places. 3 sets of species. 3 different histories. Zebra and warthog at an African waterhole. Native marsupials in Tasmania. Roe deer inside a hunting ban in China. They point at one thing. An ordinary talking voice is the mark of a human being present. Not a roar. Not a gunshot. Nothing forceful at all. Just the volume you use talking to somebody. The opening question can close here. The answer really isn't in the sound. Out in those trees, your voice is the loudest thing there. Not for its volume. For what hangs off the back of it. Draw the line before going further. These experiments measure what can be seen. Whether it runs, how fast, how long it stays alert. They don't claim the animal holds a subjective fear identical to yours. So this next sentence is narration, not a finding. What hangs off the back of that sound is a record, and you didn't write it. It was written over a long time, by a lot of people. It was already there when you were born. You inherited it. Then you open your mouth, and you carry the whole thing over. That's the part that sits worst. You mean no harm, you're only talking. But what you carry over isn't decided by what you intended. It runs because it remembers, because it's being careful, because it's staying alive, not because it hates you. So what's left that you can do? Not much, but not nothing. Keep your distance, and keep it short. If you see it drinking or feeding, leave earlier than you wanted, and leave it a steady way out. These lower the disturbance this one time. They don't guarantee the animal has no reaction. None of it makes it accept you. No point pretending. It will still run, and you still shouldn't move closer. No data anywhere says being gentle lets you get nearer to a wild animal. One thing they can do, make this one encounter lighter than it would have been. One less startle, a few more swallows of water. That sounds small. But the record was built out of small things, one line at a time. The distance between us and them, in awareness and fear and grief and love, is getting smaller. And half of what that means is this. It already knows us. We're already written into its judgment, filed under one of the columns. It doesn't need to see us to know what to do. That record is still being written, slowly, one encounter, one line. You're not answerable for the part you didn't write, but the next line is yours. That's all for tonight.